Ever pondered how radar, laser, and active acoustic devices measure distance? What magic do they perform to tell us how far away an object is? Well, it's not magic, it's science, and the principle behind it is simpler than you might think. These devices rely on a concept called time of flight measurement. Essentially, they emit a pulse of energy, then wait for that pulse to bounce back after hitting an object. The time it takes for this pulse to make the round trip is the key to calculating the distance. Let's unravel this a bit more. The energy pulse travels at a certain speed, which we'll call wave propagation velocity. This speed differs based on the medium. For instance, light travels faster in air than in water. Now, imagine the pulse as a runner in a race. The runner sprints from the starting line, our device, reaches a point, the object we're measuring distance to, then sprints back. The time taken for this back and forth journey is what we call round trip time. So, how do we get the distance from this? It's like calculating the distance a car has traveled. If you know the speed of the car and the time it's been driving, you can figure out the distance it has covered. Similarly, by multiplying the wave propagation velocity by half of the round trip time, we get the range or the distance to the object. In essence, the principle of operation of most radar, laser, and active acoustic devices is the measurement of the time between the transmission of a pulse of energy and the reception of the echo. The core elements of this principle are the wave propagation velocity, the round trip time, and the range we're trying to measure. To summarize, these devices function by emitting a pulse of energy and measuring the time it takes for that pulse to return after hitting an object. They calculate the distance to the object by multiplying the wave propagation velocity by half of the round trip time. And that, in a nutshell, is how radar, laser, and active acoustic devices measure distance. So, the next time you see a radar speed gun or hear about laser measurements, remember the runner, the pulse of energy racing back and forth. Behind the scenes, it's all about speed, time, and distance. Not so much magic after all, but a brilliant application of basic physics principles.